Okay, here they come. There we go. Look at that. Little red boys. Okay, at the top of the main file here, we're just going to slow down the speed of the enemies a bit. I've got some values off to the other screen. I'm going to declare some new variables that we'll use for the gameplay code shortly. So first of all, we'll make the large enemies 80. The small enemies 100. I've just been playing around with these to try and find a good speed. I think this works pretty well. The speed for the player, which currently I think is 600. So we'll set that quite a bit lower. It's down here, yeah. So speed player. Change that. And we're going to also add a jump velocity rather than hard coding it in here. And that's going to be set to 1350, which is also a bit lower. So we're just slowing everything down, bring it to a less frenetic pace. We're also going to introduce some new variables. So we need one for the grounded time. So we're just adding this grounded time constant, which if you've ever seen or gone through any other 2D platforming tutorials, you might have noticed that they oftentimes let the player jump even though they're technically not touching the ground anymore. So if they're running off a ledge, they'll have just a second to not a second. Okay, so you can imagine this green box is the player and this white box is the ledge, and they've just been running and they just dipped their toes over the edge. Well, you want the player to be able to still jump, because if you ever played a game that doesn't implement this, it feels really bad because our eyes are a little bit slow and we think that we're still touching the ledge, but actually we're not, and the computer knows we're not, and if we're just here, it's like, no, sorry, but to us it seems unfair. That's why we give a little bit of leeway so you can kind of be down here and then jump. That's what this timer is for. And it's going to need to be paired with a state variable, which we'll just call ground timer, I guess. Put that down here. And we're going to need a couple of other timers as well. May as well put them here. So we need a shoot timer, which is going to be, so different weapons will have different fire rates, and so this number will be increased based on the weapon type and then decreased every frame back towards 0. And we're going to do the same for a spawn timer, which is going to be when the enemy should spawn. We're going to make one more collision layer here, and that's for the projectiles. And down here we're going to make our projectile mask. So we want them to be able to collide with enemies and terrain, which actually is also the player mask. So I guess we could just use the player mask, but I think we're going to add something to this, so we won't use that. We're going to add the collision layer enemy pass through. So now players are going to collide with this layer, but enemies, projectiles won't. Enemies and projectiles. So here we'll put the terrain. Alright. Now let's just go through and change anywhere where we needed to use these variables. This is already done. Speed enemy small, speed enemy large, great. That's all fine. These can remain hard-coded. I mean, there's only 2 enemy types. Right, so of course we already had a spawn timer down here, which was declared in main. Let's just ignore, we can just ignore these things. I was just testing some bugs that we fixed. Spawn timer, so we can just delete this one because we've got the other one in global namespace, or in file namespace, I should say. Although really you could use either, considering these variables are not shared between files, they're all static, but they may be shared between functions. So anything we need to use in multiple functions, we're going to pull out of main and put up. We can just remove this code here that we commented out. Don't need that, it's all in spawn enemy now. When you've got long running code like this in a function because it's your main loop, I find it useful to just put a little comment saying what this is doing. So render terrain /map, and if there's variables declared, you can even wrap it in braces like this, which we've been doing. It's not necessary for this one. But yeah, that just keeps everything in a nice little section. You could pull it out into a function, but if you're not going to use a function in more than one spot, then what's the point of it being a function? Doesn't really make sense. So, here we can just say debug render. What are these called? Bounding boxes, I guess. We can put this in braces. Not necessary, it's just 2 for loops, but it does keep them together, so you can easily see what this is. Also, you can fold it if your editor supports folding. So now you can see there's 16 lines there that we don't have to look at. Also, if you include the comment in your fold, you can get a little idea of what this is. Debug render bounding boxes. And that's cool. Okay, I've made a little to-do list that we're going to get through. The white items are things we haven't implemented yet, and the red ones are bugs or just leftover vestiges. So the floating player sprites is just something minor. We can just delete the couple of lines of code for that. Now this bug is actually new since we slowed the game down, and I'll show you what it looks like. Okay, everything's a lot slower, but as you'll see in a second, the enemies don't turn around when they hit the wall. Now, why is that? It's because of the way our collision resolution happens. So basically, I drew this little diagram. If the enemies are walking into the wall and they're walking really slow, then let's say their movement speed is where the orange box is where they'll be next frame. So it's not quite, it's just over halfway. Let's say, well, in our case, I think it's 80. So they move at a speed of 80 if they're the big enemy. And gravity is set to 100, which means next frame they're going to be down here. And because we always solve the highest distance first, then we get this problem where we keep solving the bottom, and that's the only one we use. Every single frame, we only call the on collision event for this one, and then the other one gets handled by the stationary. One is to create a queue for our events. So when we hit a wall, it'll actually queue up both collision events and then respond to the one that's appropriate and do the physics update. So the physics stuff will stay the same. Well, the simplest way is to actually just decrease the gravity. So we're going to do that just to keep it simple. So if we head over to physics, we can see we've got gravity up here at -100, and if we go back to main, we can see our enemies move at a speed of 80 is the slowest. So if we set this to 79, then we should get the desired result. And there it is. Now they're bouncing off the walls again. It's not the best solution, but it's one that works totally fine. Just means you can't have enemies that walk slower than your gravity. Or, alternatively, instead of using the collision on the static bodies, you could just put a trigger. So you put a trigger here on the right-hand side, one on the left-hand side, and then that's it. And they just turn around when they hit the triggers instead of when they hit the walls. Or you could add the event queue, but that's way more complicated. Alright, so I'm going to mark this as done. There we go, that one's done. Floating player sprites on screen. Let's just get rid of those real quick. It's somewhere down here. Here it is. We can also delete this player color variable while we're here, I believe. We don't use that. Okay, that's good. Mark that one as done. The the enraged enemies has a dependency, which is the fire at the bottom of the level. So this is actually just a trigger with an animation. So we'll make the trigger first, and then we'll also make the enraged enemies and we'll test it out. But the trigger it has a couple of things that it needs to do. It should kill the player, and it should move any enemies to the top left or right spawn points. And for those enemies, they should be enraged. Should be enraged. and they're going to be healed as well. Okay, so... Oh, actually, we already said that up here. So they increase the move speed, they get restored HP, and they have a different animation. Alright, let's do that one real quick. So, fire at the bottom of the level. Okay, this isn't strictly necessary, but I feel like we should make a create function for triggers, because they're just bodies, but they always have a velocity of 0, and they are kinematic. They will never have an on-hit static function, so we're just going to make a little helper function here. Physics, trigger, create, and it'll take the usual position, size, collision layer, collision mask. It's always kinematic, and it'll have an on-hit event. There we go. And then internally, it's just going to be like the physics body, which is here. It's just going to call that function, actually. So we're just going to call return physics body create, pass in position, size, and this is just going to be 0. Collision layer, collision mask, true, on hit, and null. There we go. So now we should be able to create a trigger for our fire quite easily. Okay, here's the trigger. So we're going to put it in the middle of the screen, just below the screen, and it's going to have this size, collision layer of 0, collision mask of the fire mask we created earlier, and actually the on-hit function we created a long time ago, well, a couple of episodes ago, to test the fire on hit. So this isn't exactly what we want to happen, but it's good enough to test it. So let's have a look. Okay, as you can see, when the enemies hit that trigger right at the bottom of the level, they get destroyed in this case. Obviously, we want to change that functionality a bit, but that means the trigger is working, which is great. Okay, so at the moment, the fire on hit is above spawn enemy, but we're going to need to move that down just a bit, because we're going to call spawn enemy from fire on hit. So we'll just put it here. And then rather than, actually we do want to do this, we want to disable the entity, disable the body, and then we want to spawn a new entity, which is enraged. But how do we know if it was a small enemy or a large enemy? That's kind of the problem. Well, I suppose what we can do is check the size or the velocity. So we say if the body velocity dot x, oh no, it's not that in this language. If the body velocity on the x-axis is equal to speed enemy small, and we'll make this absolute. I think there's a float version. If the absolute value is equal to the speed of a small enemy, then we know we have a small enemy. And so what we can do is we can spawn an enemy, and it is small, and it is enraged. And is it flipped? Let's just figure that out. So we'll just do this. Yeah. We'll just roll the, not roll the dice, we'll flip a coin here. There we go. So now we should get an enraged small enemy whenever a small enemy falls down. Let's just have a look. Okay, let's see. Bam. Yes. He's definitely enraged, but his sprite hasn't changed. And when he hits the wall, he slows down again, which is not what we want. So the problem we have with the enemies not knowing that they're enraged, I think you can sum it up as we don't have a way to store arbitrary data about an entity. So that could be flags, or it could be some amount of memory where you can just put stuff that you need or whatever. And in this case, we don't have that. So we've got animations, we've got masks, we've got velocity, and we've got this is enraged boolean that gets passed in. So using some of this data, we can probably figure it out. If we go to the onHit static, you can see we're always setting it to speed enemy small, which means if they're enraged, they get slowed down. If we could get the animation that's currently being played, then we'd know that it's enraged, because when we spawn it, we'll actually pass in the enraged animation. That's one way we could do it. We could check to see what the speed is here, and if the speed is equal to 1.5 times the speed enemy small, then we want to, yeah, I don't know if I like that is it possible for us to do something like this? F32 speed equals speed enemy small. No, sorry, the speed is going to be self velocity on the x-axis. So we take the absolute value of the speed, and then in here we just put that, and then in here we put negative speed. So this should actually flip it around without using the preset number. Let's just see if this works. That definitely does not work. And I think I know why. Because they're constantly hitting the wall and reacting to that event kind of over and over again, and they get stuck there. That's why I had it set like this. Otherwise they would keep flipping around. You know what, I think I'm just going to give an entity some arbitrary field that they can have data written into. So over here we're just going to put usize flags, and that's 64 bits that we can just write data into. Now really one of these should be isActive, since that only takes 1 bit, but we're just going to leave it as it is for now. If you wanted to optimize this for space, if you have a lot of entities, then I would put the boolean as one of the bits in the flags. Okay, we've actually got another problem here, which is these functions all running on body, right? Not on entities. So how do we get the entity? Now we could put the arbitrary data onto the body as a quick hack. Don't really like that. The body could store its own ID, I suppose. So if we have a look at physics, body create. So we've got an ID here, and what if we just set the ID as well on the body? Then we could get ID of the body, and then we could get the ID of the entity by looping through. It's kind of roundabout, isn't it? Okay, so we've got this coupling problem at the moment. Or rather, we don't have coupling of the physics system to the entity system. So there's no way of getting the ID of the entity that any body belongs to. So when we have an onHit event, we don't know anything about the entity, which means we can't use any data that's stored on the entity. Yeah, basically, I mean, what's the point of having onHit events on bodies where you can't access any of the context about what they might be hitting? Alright, so I think what we're going to do is we're actually just going to tightly couple these. If you don't want to do that, I can think of some alternatives, but one is you have some kind of arbitrary data that you can specify on a body, and then you just access that data to do whatever it is that you need. Another is you keep a separate mapping. So you've got some kind of map of entity to body IDs, and here you just have a series of IDs, let's say 0, 1, 2, whatever, and then they will map directly to the body IDs, arbitrary numbers, because once the bodies are not used, they become inactive and they can be reused without changing the array. Alright, and then you have a body IDs to entity IDs mapping as well. So this could be an array, this could be arrays, or they could be hash maps. But yeah, basically they would work like this. So right now we're storing the body on the entity, body ID on the entity, and if we want to get the entity from the body, the only way we can really do it is if we store the body ID somewhere, like on the body, or if we store the entity ID directly and then use it directly. So we're probably just going to do that as the simplest solution for now. Just note that it does make these two systems tightly coupled. Well, they're not tightly coupled, but they are coupled. So if there's no entity ID, it won't affect the physics system if the entity IDs are wrong, because the physics IDs, because the physics don't call any functionality that has anything to do with entities, it's not going to break if you have bodies that don't have entities attached. So I think by default, we're just going to set this to -1 cast to a size, a usize. Okay, so in the physics body create function, we're now going to add an entity ID, and we'll just put that on the end here. Make it a usize. Now everything's going to break. Conflicting types, so we need to go into the header file and change that. What's the problem with this? Does not refer to any field in the body type. Yes. We'll just put that up here. And too few arguments to function. Yeah, so this is going to be usize -1. And I think we should be getting build errors elsewhere. There we go. Okay, here we go. We have the ID here, so we can just pass it straight in. Okay. Now, the cool thing about this is, I mean, yeah, they're coupled now, but we can just get the entity. So entity equals entity get self entity ID. And we won't worry about that. Speed enemy small. We'll set these back to what they were before. Alright, so now I've got the entity. What do we know from that? Entity, we've got an animation ID, which is pretty useful. We've got some flags that I said I was going to add. Now, we don't need both of these, but I mean, at this point of the game development, you got to ask yourself, how much do you care about polluting this entity struct with another thing? So you could just say is enraged right here. And yeah, the only thing that's going to use it are the enemies, but you only have 3 entity types. So I think the trade-off might be fine. So if entity is enraged, then we will times the speed by 1.5. So we're just going to put that down the bottom here. If entity is enraged, then self velocity 0 times equals 1.5. There we go. Of course, we're going to have to actually set that when we create the entities here. We don't want to make this part of the entity create. So what we're going to do is get the ID back, get the entity, pass in the ID, there we go, and then we'll set the is enraged to is enraged. Not too tough. I have to do it for both of them. Yeah, we're repeating ourselves a little bit in this function, but it's only a few lines. Alright. Oh, I accidentally deleted it. There we go. Actually, you know what? I am going to change this. It's too annoying. Vector size, sprite offset, and velocity. Nope, velocity. So we'll just say if is small. Sprite offset is going to be set to 0 and 10. And we also need a collision layer, which I think... Oh yeah, that's a better idea. So what we're going to do is we're going to do this. 20, 20. We'll initialize the values as the large enemy. 0, 10. And we can just get rid of this whole clause. Collision layer is the collision layer. No, we don't need that. We need the animation ID. Equals anim enemy large ID. If it's small, then we'll set it to small. Okay, there we go. Just about. Okay, so up here we set the values, and then down here we need to actually fill these in. So position size is fine, sprite offset's fine, that's fine, that's fine. This should be animation ID, and this one should be on hit static. There we go, and all should be well. Alright, we've got a definite bug happening up here. Check this out. They're just like appearing and zooming off into the stratosphere or something. Yeah, right. So when we said every time the enemy hits something, then we want to set the velocity times equals 1.5f. That's definitely not what we want. So we'll just say if entity is enraged, then we actually want to set it to time minus this times 1.5 or negative speed enemy small times 1.5. Else we'll set it to the default value, and we do the same thing up here but without the negative. Alright, now they shouldn't be flying off into the stratosphere anymore. Let's have a look. Alright, great. They are noticeably faster. When he hits the wall, he shouldn't slow down. Yes, good. Alright, they're not red yet, but we can do that next. Also, this needs to happen with the large on hit static. So I'm just going to copy the inside of this and paste it here. And then just delete that. Change these to large. And there we go. Now the large enemies should speed up too. Alright, here we go. It's going to fall in. Bam. Where is he? Oh, you know what? We actually need to update the fire as well, because this is only happening for small enemies. Why did we decide this? No, this is how we're checking if they're large or small. So if the speed is enemy small, then we do this. But what if it's enemy small times 1.5? This will do that as well. So we check both of those, and this is not great code. I don't like this too much, but we're so close to being there, you know? And there being the end of this series. Is small. So this would be false. I suppose actually what we could do here is we could just say spawn enemy, and if the absolute velocity is equal to the small speed, or it's equal to the small speed times 1.5, then actually we don't need you to use the velocity here. We've got the entity, animation ID, small, or small enraged, which we haven't created yet. Okay, there we go, and now we just say is small. Delete this, delete all of that. This is much better. So we're gonna go up and create this small enraged animation. Just up here. So it's the same, it's actually exactly the same as these two, but I'm gonna add enraged, and the row is gonna be 0. And that should be the same. And I guess here we just copy those. Enraged. Change these to enraged. What's this true referring to? Does loop? It does loop indeed. Now we'll have to find these. There we go. Okay, now we should have enraged IDs, but we haven't set them yet. When we go to the spawn enemy, if it's enraged, we also want to change the animation ID to, yeah, if it's small, then this one. Otherwise, there we go. Now hopefully this will give us what we want. Okay, here they come. There we go. Look at that. Little red boys. No large ones. Again. Because why?